types of reactions the haloalkanes undergo are nucleophilic substitution reaction under mechanism SN1 and SN2, and elimination reactions mechanism under mechanism E1, E2, E1CB, and reaction with metals. We have discussed the SN1 and SN2 mechanism with examples. That is over. Let us take up the elimination reactions for a discussion. What is meant by elimination reactions? In this case, broadly we have two types, that is alpha beta elimination and alpha gamma elimination. What is this? This is hydrocarbon. These two are adjacent carbon atoms. There is a carbon, the hydrocarbon molecule. As you know, each carbon is bonded with 4 chemical bonds, tetravalent. And to this carbon, the B is bonded and A is bonded. And this A and B can be eliminated by breaking of chemical bond, attack of reagent. This A and B is eliminated as AB molecule, that is chemical bond breaks, then new chemical bond forms. These two are sigma bonds, and between the two carbon atoms, sigma is there, next bond is pi bond formation, that is alkene formation. It is known as alpha beta elimination. The two adjacent carbon atoms are named as, one is alpha, other is beta. That is alpha beta elimination. What is alpha gamma elimination? Here it is organic compound of same type, but 3 carbon atoms are in sequence. Here are 2 carbon atoms adjacent. They are in sequence, and these carbon atoms are numbered as alpha, beta and gamma, but written like this, it is linear. To this carbon, that is atom or the group is bonded A, and B is bonded to this. If A and B is eliminated, breaking of chemical bond, breaking of this chemical bond, when A and B is eliminated as a molecule, then there is no chemical bond. A new chemical bond is forming. This is sigma bond, of course, like this. With this elimination, this new bond is forming. Look at this, the compound is cyclic compound. It is called cyclic alkane formation. That is alpha gamma elimination gives cyclic compound, and alpha beta elimination gives alkene compound. Now the syllabus is restricted for alpha beta elimination. In this alpha beta elimination, again we have 3 types. That is, one is E1, that is E1, E1CB and E2 mechanism. That is, CB stands for conjugate base. So what is E1? That is same compound here in this compound. This is A, this is B. A is H. It is 2 adjacent carbon atoms. This is halogen atom. So these two can be eliminated as HX. So in this E1, there are 2 steps are involved. First, X is removed. X is removed as X minus, resulting in the formation of carbocation. Then H is removed as H plus, nullifies this charge, becomes double bond. So first X is removed as X minus, then H is removed as H plus, resulting in the double bond. So when X is removed, we get carbocation. Then this H is removed, these electrons, bonding electrons, here that is taken back to carbon atom, forming a pi bond. It is removed as H plus, alkene formation. 2 steps of reactions involved, that is E1. And E1CB, that is conjugate base. Here base is a usually weak base. conjugate base is involved. Now it is exactly reverse. Again two steps of reactions. First H is removed as H plus, then X is removed as X minus. Look at the difference. First X is removed, then H. Here first H is removed, then X. So if H is in the first step, if H is removed as H plus, this carbon becomes carbon anion, negative charge, and this chemical bond breaks, taking H plus, and these two electrons remain on the carbon as carbon anion. Then X is removed as X minus, then nullifies this charge. This is removed as X minus, then these electrons form a pi bond alkene formation. It is known as E1Cb. Then what is E2 mechanism? That is, E2 means elimination. Here two steps are not involved, only single step is involved in this reaction. This is once for all. In a single step, these two chemical bond breaks, and this is removed in one step as HX molecule, and resulting in this breaking of chemical bonds forming new chemical bond. Like this is one step reaction, not two steps. So E2 means single step reaction. E1 means two step reaction. So these are known as elimination reactions. In brief, that is one. This differences, what is that? E1, that is mechanism of E1, mechanism of E1Cb, mechanism of E2. It depends on what is that, the reagent we are using, the solvent that is using, and the carbocation that is involved in this. This all depends on this mechanism. That is, those reagents will make the difference in these mechanisms. And most importantly, we need to talk about today's elimination, because we studied already know what is SN1 mechanism, and E1 means that is elimination. But elimination reactions are endothermic. SN1 reactions are exothermic. What is exothermic? Heat is liberated. What is endothermic? Heat is absorbed. So you have to supply heat into the system. You have to supply heat to the molecules to what is that? Eliminate. Forcibly we are doing it. That is endothermic. Endothermic means at high temperature. It requires a system required to be heated. So it is more than 50 degree. The temperature required is more than 50 degree for this even elimination. What about SN1 mechanism? That is at low temperature. This temperature is liberated, heat is liberated. That is less than 20 degree. At low temperature, exothermic. Exothermic means low temperature, it is spontaneous. Reaction is possible at low temperature. At high temperature, this reaction is spontaneous. That is, reaction is possible at high temperature. That is the main difference. E1 and SN1. There is always a competition in the reaction between E1 and SN, E1 and S1 mechanism. Let us see what is the mechanism involved in E1. The mechanism is that E1 unimolecular elimination. What is E1 means? Unimolecular elimination. What is the first step is similar to SN1 mechanism. I told you, it is a formation of carbocation. Carbocation is the formation. It mainly depends on carbocation formation and stability to maintain the carbocation, and the atmosphere, the solvent, and all factors. What is that? Carbocation stability and the leaving group and the solvent all plays an important role. The same what I explained in the last class, SN1 mechanism. All these factors plays an important role. That is weak base. Weak base is the one. It is the one favoring this. And carbocation, stability of carbocation, it depends on this and this. Tertiary carbon like this. And the presence of substituted, that is substitution with the carbocation, plays an important role for stability of carbocation. And that is solvent, that is polar protic like water and ethanol, that is water and alcohol. This plays an important role for the formation of carbocation, stable carbocation, and also importance of this presence of halogen atom, that high and Br. The presence of I and Br will favor this carbocation formation. They are good leaving groups. So with all this, the same condition applied for this carbocation is a SN1 mechanism and E1 mechanism. So E1 mechanism means what is that? Same as rate of reaction. Similar to this, that is a slow step. This is X is slowly removed. X is slowly removed. It is because of weak base. That is, if the strong base is there, that strong base will not wait for elimination of X minus. It will attack immediately. It will not wait for elimination of X minus to become carbocation. That is why weak base is a must. Strong base will not do that. That is favoring this. And this is a step, is a slow step. This step is of course the first step. The rate of this reaction is elimination. The rate of this reaction depends on the concentration of this. And there is no other reaction, that is concentration of base to the power of 0. So rate is not depending on the concentration of base in this. It is carbocation formation by itself first. So it is a first order reaction. E stands for first order reaction. That is, 1 stands for first order reaction, E stands for elimination reaction, unimolecular elimination reaction. So these are the conditions for the formation of carbocation. It is same as the mechanism as SN1 mechanism. Next, after the formation of carbocation, that is very important is this, that there are two possibilities. If the temperature is lower temperature, that is less than 20 degree like this, so it will undergo nucleophilic attack. That is carbocation, that is Br minus is removed, is carbocation formation. This carbocation formation at low temperature, this is a solvent, that is methanol is a solvent. This solvent, that is methanol, is acts also as a base. Acts as a base, that is, so CH3CO nucleophile at low temperature. So this solvent is a polar coating and acts as a nucleophile. There is a nucleophile generator. This nucleophile will have the carbon atom. There is SN1 mechanism at low temperature. Favors SN1 mechanism. If the temperature is high, the same solvent and the same base, that is methanol like this or water like this. At high temperature means heat is supplied. At high temperature, heat is consumed, and the presence of weak base will break this chemical bond because CH3 is there, one of the hydrogen, that is this chemical bond is breaks and remove as H plus, and these electrons forming what is forming a 5 bond with this, and HX is removed. At high temperature, base and temperature plays an important role. That is for the breaking of this chemical bond, elimination of hydrogen as H plus, forming alkene. So that is a mechanism involved in even unimolecular reaction mechanism. Next. So that is what is the weak bases are water and this favoring these reactions. That is, the factors favoring this are similar to SN1 mechanism. Now with this idea, that is mechanism, let us see examples of what is that. That is examples of this E1 mechanism and SN1 mechanism. There is always a competition between E1 and SN1 mechanism. Let us see different examples. Haloalkanes. Here are different haloalkanes. Here CH3, CH2, CH, CH3, Br. That is 4 carbon atoms in a chain. Br here. So this undergoes both SN1 mechanism and E1 elimination. The conditions are, if temperature is less than or 20 degrees centigrade and solvent is CH3OH and CH3OH itself, that is nucleophile generator, then this Br is removed first and this, that is OCH3 is attacked as nucleophile forming SN1 mechanism. If the temperature is 20 degree, if the temperature is 80 degree, same solvent, what happens? The reaction is different. It is not the attack of this nucleophile, it it is a removal of what is a beta hydrogen, next hydrogen atom. There are, look at that, this is alpha hydrogen. Now beta hydrogen, the hydrogen of this carbon is also called as beta. The hydrogen of this carbon is also called as beta. So it can be either this hydrogen is removed or this hydrogen is removed. Both are possible. Both are beta hydrogen, adjacent hydrogen. If this one of the hydrogen is removed, we get this alkene. If this hydrogen is removed, we get alkene, the pi bond formed between these two carbon atoms. That is a compound. Here butene, butene. Here one butene, two butene. Same molecular formula, different structures. That is structural or positional isomers. These are structural isomers, different structures. And you see that both compounds are formed, but this compound is in minor, this compound is in major compound. So what is the reason for this? It is depends on the stability of the alkene, the stability of the double bond, which is more stable among these two. This is more stable, this is less stable. That is in accordance with what is that? A rule, that is Sedgwick rule. What is Sedgwick rule? It means that is this double bond is alkane is there between this carbon and this carbon. And see the next carbon, that is next carbon is this, next carbon is this. The hydrogen atom of this carbon, these hydrogen atoms are called as alpha hydrogen. This is not alpha hydrogen. That is double bond, leave the double bond carbon atoms. And next carbon with this is called alpha hydrogen atoms. They are called alpha hydrogen. That is a rule based on this. And when you look at this pi bond, when you look at this pi bond with this carbon and this carbon, there is no carbon on this adjacent side. This carbon and this adjacent side is, this is C. This has two alpha hydrogen, only two alpha hydrogen. So this has only two alpha hydrogen, this has six alpha hydrogen. According to Sedgwick rule, the alkane which is more alpha hydrogen or more crowded hydrogen, more substituted hydrogen around this double bond is a stable alkene. Stable alkene. And one which is having a less alpha hydrogen is called less stable. That is, this alkene is less stable, this alkene is more stable. That is why we have 80% of this isomer formation. This is only 20% of this isomer formation. So there is even mechanism. This even mechanism you get. Again, when you look at this isomer, structural isomer, you can have two different, what is that, structures. That is configuration, geometrical configurations. So in the same molecule, you can have a configuration like this, configuration like this. Same, it is geometrical configuration. In this, it is trans, CH3, CH3 on the opposite side. Here, CH3, CH3 on the same side. Because of bulky group, steric hindrance, eclipse, and here this alkene is less stable. That is interact, that is eclipsing, forming what is that, less stable. But these are what is staggered away from each other. More steric hindrance, it is more stable. Trans is more stable and cis is less stable. That is why among these, what is that, we have two configurations. This is 80%, this is 20%. Among this is 80%, this is 20%, in accordance with Sedgwick rule. But in accordance with cis-trans configuration, this configuration is more stable. So that is in even elimination cases. But in case of this second example, other example is this one. Now the same idea is extended to other examples like this. Here the compound is, that is the hydrocarbon molecule CH3, CH. There is one side chain CH3, CH2 and Br. Let us see what is first carbocation formation. Then second step depends on what temperature, that is SN1 mechanism or E1 mechanism. See, first step is elimination of Br minus, carbocation formation. Here carbocation formation is a primary carbocation. Now look at any chances, what is that, any rearrangement, any possibility of rearrangement which leads to a carbocation which is more stable carbocation formation. That is also possible. Look at at this carbon, this has hydrogen, this carbon has CH2. So it can shift, plus can shift from this carbon to this carbon by shifting H minus from here to here. It is hydrate shift. That is possible rearrangement. If there is any kind of rearrangement with the adjacent carbon, then that undergo rearrangement, that is hydrogen shift, hydrate shift. From this to this becomes minus, that is charge nullifies, this charge is coming on to this carbocation. Look at this carbocation is tertiary. Tertiary carbocation is what is that? More stable than primary carbocation. So this arrangement takes place after the carbocation formation, becomes more carbocation, more stable carbocation. Now with this carbocation, this is alpha carbon. There are two possible reactions. That is, water is a solvent. Water also acts as a nucleophile. That is base water at 10 degrees centigrade at low temperature, and that generates what is that? Hydroxyl ion. That nucleophile attack this carbon, forming SN1 mechanism at low temperature. The same water at high temperature, 60 degree temperature, it is elimination. That is, they beta, what is that? Beta hydrogen atoms here, beta. This carbon, this hydrogen atom was adjacent now. Adjacent to this carbon, the carbon with hydrogen beta, the carbon with this hydrogen are beta hydrogen, all these beta hydrogen. So all are similar. So if you remove this hydrogen, you get this carbon. So when you remove the same kind of structure you get almost, because this is what with the removal of H plus at this temperature, this hydrogen, one of the hydrogen is removed, chemical bond breaks and removes as H plus and forming double bond. This H plus and Br forming HBr. In both the cases, HBr formation is a byproduct. That is E1 mechanism at this temperature. Water is solvent, water itself produces what is a base in this case, this attack. In the other example, but is a different organic compounds are involved. Here different this is one kind of organic compound, haloalkanes. This is another type of haloalkanes, and this is another type of haloalkanes. That is cyclic hexane with the side chain. That is side chain. And the vertex already told you, that is the vertex is CH2, 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 CH2. This is CH2. This is already three chemical bond CH, and this end is Cl. So understood. So this is when this, that is a 60 degree. When it heated at 60 degree in presence of methanol, undergoes what is the E1 mechanism. I am showing E1 mechanism in this case because this temperature and this solvent undergo E1 mechanism, E1 elimination. First removal of Cl minus, here resulting in formation of carbocation, primary carbocation CH2 plus at this point. Then this carbon here with hydrogen, it can have a shift. What is that? This will shift from here to here with the exchange of H minus, that is hydrate shift from here to here, forming the same kind of what is that rearrangement. This plus is shifting onto this carbon. This carbon is tertiary carbon, this carbon is primary carbon. Tertiary carbon is more stable, then can undergo this kind of rearrangement. And this carbon is now called as alpha carbon. Look at this carbon containing carbon plus charge, carbocation. This is alpha carbon. Then what are beta carbon? That is next adjacent carbon is here, another here, and one more CH3 here. These are beta hydrogen with this carbon, beta hydrogen. There are two hydrogen, there are three hydrogen. So this and this are same, no difference. This is different. If you remove this hydrogen, it becomes like this, CH2. This. Then another possibility is, if you remove this hydrogen, what is the hydrogen of this carbon? Either this or this, both are same. You get this carbon. What is that? Alkene like this. Double bond between this carbon and this carbon. If you remove H plus from this, becomes alkene here at position. So this is minor, this is major. Again, on the basis of Seitzak rule, we can say on the basis of this rule, we can decide Why it is a major compound, why it is more stable, why it is less stable. Look at that on the basis of calculation of alpha hydrogen. So what are the alpha hydrogen atoms with this alkene? That is CH2 is there, next there is no carbon. There is no carbon, adjacent carbon. Here adjacent carbon is this and this. Here CH2, CH2. That is 2 hydrogen, 2 hydrogen. So alpha hydrogen 2 plus 2 is equal to 4 alpha hydrogen in this alkene. Let us calculate what are the number of alpha hydrogen atoms in this alkene. This is alkene. This is between these two carbon atoms. The adjacent carbon here, the adjacent carbon is here, adjacent carbon is here in this alkane. Here CH3, 3 hydrogen, CH2, 2 hydrogen, CH2, 2 hydrogen, 7 alpha hydrogen. So this alkene has 7 alpha hydrogen. So one which has more substituted hydrogen, that is said, so this configuration is more stable. This alkene is more stable, cyclic alkene is more stable than this. That is why we get minor, both are mixture. Here minor compound and major compound. This is on the basis of what is the different types of haloalkanes and then molecular structure. We say that which is major, which is minor, both the reactions are possible. Next, the last example, this is what is that open chain, of course, with branches. CH3, CH3, CH. Here CH, CH3. Yeah. CH, CH3. Next, with this, what is that? Elimination. First, Br is eliminated, become carbocation. That is CH, CH3. That is secondary carbon. Now the carbon with hydrogen. If the rearrangement, shifting the hydrogen from here to here in the form of H minus becomes what is a plus here and nullifies this. That is CH2, that is C. This carbon becomes, that is secondary carbon, this becomes tertiary carbon. Tertiary carbon is more stable. Now with this rearrangement, then the second step is very important. First step is this elimination, second step is rearrangement if possible. Yeah, rearrangement is there. After that, second step is there are two types of mechanism, SN1 mechanism at 10 degrees centigrade and 60 degrees is the E1 mechanism, elimination. So it is hydroxyl, attack of nucleophile hydroxyl, that is a SN1 mechanism at this carbon, that is the compound formation. If E1 is there, look at that, this is alpha carbon with carbocation, that is CH3, CH3, CH2. So hydrogen is, these hydrogen are alpha hydrogen. These two are same. So if you remove hydrogen from this or this both terminal, you get this compound like this, alkene like this. If you remove H plus from this, you get this. If you remove H plus from this, you get this. This is CH3, CH3 remains same. So among this again major and minor, more stable, less stable. It is again based on the what is that Sedgwick's rule. So the first configuration is this minor. Calculate the number of alpha hydrogen. Here there is no adjacent, they are adjacent, there is CH3, CH2, CH3, CH2, 3 plus 2, 5 alpha hydrogen with this alkene. And how many alpha hydrogens are there in this? C and C. Here CH3 adjacent, CH3, CH3 alpha. So 3 plus 3 plus 3, 9 alpha hydrogen. So this is more substituted. This alkene is more stable, this alkene is less stable. So forming a minor product, forming a major product with the even elimination at 60 degrees centigrade. At 60 we get this mixture. At 10 degree we get this. That is alcohol. And this is alkene. So these are the examples just to understand. That is very important from the point of examination. We have different haloalkanes. That is different structural formula. We get different, what is that? Different types of product with a mixture of products, major and minor. So these are the examples very important from the point of examination. So let us wind up.